Hello, my math friends. We have a question from Humar. He asks, please tell me this. Well, no, the real question is, in circle L, what is the measure of angle MNP? The first thing we need to do here is identify that angle MNP. So we know where we need to look first. So that's the angle. Now, geometry is very easy. There's nothing really that goes beyond some basic algebra, adding and subtracting, dividing, multiplying. But what makes geometry tricky for a lot of people is that they don't know the rules and shortcuts and definitions. And that is the key to being successful in geometry. And I'm going to show you what the shortcut is for this problem. Here we have a quadrilateral, four-sided figure, inscribed a circle, or inside the circle. Now, the shortcut here is when you have a quadrilateral inscribed a circle, the opposite angles are supplementary. So what that means is that the measure of angle MNP plus 73 degrees is going to total 180 degrees. Now that being said, this is so easy to solve. We just solve this like an equation, and we get the measure of angle MNP equals 107 degrees, and you're done. Very easy, right? But if you didn't know that shortcut, if you didn't know that relationship between quadrilaterals inscribed in a circle, then you would have been lost. So I want to emphasize in geometry, as you continue on your course, pay attention to the vocabulary, the rules, the definitions, the postulates, the theorems, all these little shortcuts that help us get through these problems. Now I'm going to show you this problem in another way. It's a more roundabout way. And you might be asking, why would you show me a longer way? Well, my purpose is to show you other special relationships that will be useful on other problems that deal with circles. And so that's why I'm going to do that. So let's say that we didn't know this relationship here. You could have done this by using the concept of inscribed angles and its intercepted arc. So I'll talk about what that means here in just a second. So what I'm tracing here is this arc, and I'm going to find its degree measure. So 84 degrees plus 70 degrees is 154 degrees. That is the measure of this arc right here. Now we have an angle that we want to look at, which is NPQ. And you'll notice that it's, when we look at this angle here, and we look at its extending rays or segment that create the angle, they end up at the same endpoints as that arc. So that's what we call an inscribed angle, specifically because its vertex is on the circle. Inscribed angles, vertices are always on the circle. So when you have an inscribed angle and its intercepted arc, there's a fun little shortcut here. This measure is always going to be half its intercepted arc. So 154 divided by 2 is 77 degrees. Okay? Then we're going to take a look at another arc on the other part of the circle. So we'll use the same endpoints N and Q. So arc NPQ or QPN, can go either way. The measure of this arc, well, how do we figure that out? Well, I know a full circle is 360 degrees. So I'll just take 360 minus the blue arc, NMQ, which is 154. And that's going to equal 206 degrees. The measure of this arc is 206 degrees. Now we're going to look at its intercepted inscribed angle, and that would be this angle right here, because again, its endpoints are the same as the endpoints of that arc. And we'll be looking at this measure. Again, an inscribed angle has its vertex on the circle. So we have the measure of this angle will be half of that arc. So 206 divided by 2 is 103 degrees. And finally, we're going to figure out the measure of this angle right here, which is the goal of this problem. Well, this is a four-sided figure. A quadrilateral's angles always add up to 360. So we can take 360 minus 103 minus 73 minus 77. So if you put that in your calculator, you should get 107, which is true. So just check that on my calculator. So the measure of this angle is 107 degrees. And you see that we get the same answer. Again, another longer way to figure that out. However, we learned something here. We learned what inscribed angles are, and those are useful in other circle problems. So I hope this was helpful. You need some one-on-one tutoring, feel free to contact me. Thank you so much. Bye.